Hello, my dear students. Welcome to this session on thermodynamics. Today, our topic is the unsteady state problem. This is a very important topic for the GATE examination. Usually, you can find maximum amount of questions from this area. So, we will see in very detailed manner. Before starting this unsteady state problem, I want to recapitulate the fundamentals on the steady state problem. What is steady state, my dear friends? If I take a system, the system possesses some properties like mass, pressure and temperature, which is not a function of time. Then the state of the system is steady state. More precisely, if I tell, the system having some properties which are not changing with respect to time, then the system is said to be in steady state condition. Correct? If it is a function of time, then the system is in unsteady state condition. This is the basic difference, my dear. Because system properties will change with respect to time, then it is a unsteady state condition. If not changing, then it is a steady state condition. The more challenging equation in thermodynamics is the unsteady state condition equation, because the people don't apply the mass and energy conservation equations. This is the maximum people will do the mistakes. So we will try to clarify those doubts in this lecture. So the famous example of the unsteady state condition problem is, all of you know, I think, this is charging or discharging of a system. Means if I take a example of, for this instance, if I take the mobile example, mobile having some battery, right? If you charge mobile, battery gets heated, right? Before, means at the time of charging, let us say the temperature of the battery is a room temperature. After some time, means let us take 10 minutes time, after the 10 minutes time of interval, the temperature will build up, means it will increase. There is a temperature gradient with respect to time, right? So property is changing with respect to time. So then this is the unsteady state problem. We will see in thermodynamic point of view. Okay, because we are dealing with the thermodynamics, right? Okay, my dear, this is very simple concept. Let us take a pipeline. Most of the questions come from like this only. Pipeline means, in this pipeline, air is going. Air is going with some parameters, means some enthalpy is there. Prefix P represents the pipe, okay, and some internal energy will be there, and some velocity will be there. I think, you hope you know what are the small h, u, and v. Small h represents the specific enthalpy, small u represents the specific internal energy, v represents the velocity, means air is flowing with velocity vp. Okay, if I connect this pipeline to the wall, there is a wall, sorry, there is a wall here, control wall, we are controlling the wall, and this wall is connected to the balloon. There is a balloon. Initially, balloon having some mass here, because I'm generalizing the concept, you can apply anywhere. So initially the system having some mass and pressure and temperature. Okay, so the moment when I release this valve, the air will rush into this balloon, right? After some time, the balloon will expand, means like this. Till what time the air will go into the balloon, this is the main agenda, means criteria. Correct now? See, let us say the pipeline pressure of air is in P naught. In pipe, the air is flowing with pressure P naught. Initially, there is a pressure P1. Correct now? Some mass is there, so that it will exert a pressure P naught, P1. Initial condition. So the moment when I release the wall, the air is rushing into the balloon, so a balloon will expand. So till what time the balloon will expand, means it will go to continuously, or it will go some time after it will stop. That is the question, right? So what will go? If Initially the pressure is P naught in pipeline. The pressure is initially in the gas balloon is P1. Correct now? So with the moment when I release the valve, the pressure is keep on increasing. Till what time it will increase? Till P naught. Correct? So that there is a mechanical equilibrium between the pipeline and the balloon. It is achieved clearly. So after some time it will shut off the airflow. Means if you open, still if you open, there is no problem because air is continuously flowing like this. After some time mechanical equilibrium is reached, there is no flow, it will stop. If you close or open, that doesn't matter. Okay, clearly. I hope you understand this one. Means until mechanical equilibrium is achieved, the state of equilibrium is achieved, so that there is no flow of air anymore, so it will stop the airflow inside the balloon. So if I talk state 1 and state 2, balloon at state 1 means system at state 1, system at state 2. Because my balloon is my state system, means if I take this is the control volume, because we are dealing with the open system here, not closed system. Because why open system is mass is coming into the system, right? Definitely it is a open system. So initially the system possesses some mass, some pressure, some temperature. After releasing the valve, the mass is entering into the system, so that it will go to some other state, means M2, P2, T2. Correct, right? The event is occurring in what time? Delta T time. Means finite interval of time. Finite interval of time. Correct? I think this is clear. If this is clear, nothing is there in question. Whenever if you want to analyze this type of questions, you need to apply the two principles, two major equations. So that the fundamental equations are mass conservation and energy conservation. We will see one by one. So we will first apply the mass conservation equation. I will shortly write MC. Okay, mass conservation equation. Mass conservation equation will represent like this. M dot represents the rate of mass flow rate into the control volume minus rate of mass flow rate out from the control volume, which is equal to rate of change of mass of the control volume. Simple, my dear. But this is in rate form because the differentiation term is there now. This is in rate form. This is in rate form. But this is taken in finite interval of time, not continuously. After some delta t time, it is getting stopped because the system is undergoing mechanical equilibrium, so that there is no flow of air inside the system after some time. Correct now? So that it is in rate form. I want to write in the finite interval of time. How to write? Mathematics is will help us. So if I multiply dt on both sides, what is going to happen? Just basic calculus, my dear. If I integrate on both sides, because dt time interval, it is going mass in. It is dt time interval, mass is going out. Okay, it is a change in the control volume. If I integrate, already I have no limits from state 1 to state 2. Correct? From T1 to T2 time. From T1 to T2 time. Some mass M1 to M2. Correct? See, if you see the rate of mass is going into the control volume is in which units, my dear? In kg per second, right? In what time? Second, dt time. So my if I integrate this term, I will get only mass into the control volume. Means net mass is going into the control volume in kgs. Correct? Mass out from the control volume. Net mass is equal to change in mass of the control volume. For this condition, I have taken this system as balloon. There is no flow of air out from the balloon, so that this term is 0. In some questions there will be mass flow out also, rarely you will get. That is not a problem, because I want to say the concept. That's why I am telling. Whatever the mass is entering into the control volume, which is equal to the change in the mass in the control volume. Correct. Whatever the mass is entering, the change is equal to the entering mass. This is all about the mass conservation. If it is over, then we will go to the energy conservation. So we will start energy conservation. This is very easy concept, my dear. If you solve one question or 2-3 questions, definitely you will hit every problem. Now energy conservation I am writing easy. Okay. Energy conservation. So energy conservation also similarly in rate form, it's like this. E dot into the control volume. E represents energy into the control volume, energy out from the control volume, which is equal to rate of change of energy from the control volume. Correct? It is in rate form, because this is very important. Rate form, when we can apply, whether it is a continuous process. Correct? If you know the function, then you can differentiate it. There is no function at all. It is in finite interval of time. So that you have to change this one into finite interval of time. For finite interval of time, all of us know already. Because if I write again, same thing. If I apply, multiply with dt on both sides, and after that integration, it will become the same thing. Correct? If you know mathematics, engineering, 70% engineering over, my dear. See, system is going from T1 to T2 because already limits are specified. Known limits. Energy, initially, see, when system having some property, definitely the system having some energy, right? So energy E1 to E2. Correct? So final equation will be energy in to the control volume minus energy out from the control volume, which is equal to rate of, sorry, not rate, it is change of energy of the control volume. Correct? We should know the what is the term E2 and E1. See, in the generalized form, E written as, it is the summation of energy of the internal energy. Internal energy means energy possessed by the air molecules by of its own. This is the internal energy, U. And also with it is having some kinetic energy, because molecules having some kinetic energy, na, it is flowing in motion, right? And also it is having some potential energy if it has some data. Correct? If I take this as the data, so molecules will segregate here, so there is a data, it will experience some data. So definitely there will be a mass of molecules, and g is the acceleration due to gravity, and height is the data. So if I write E2 minus E1 is U2 minus E1 plus half into m is constant, V2 square minus V1 square plus mg H2 minus H1. Correct? Till this there is no problem. I think we will go to next board, because till this no problem, right? Because see, energy associated with any of the system is comprises of three terms. One is internal energy, one is potential energy, and one is kinetic energy. Okay, this I am writing in difference form. U2 state 2 minus state 1 plus state 2 minus state 1, state 2 minus state 1. Up to this clear? I hope this is clear. Then we will go to the next board. This is important because nobody will tell you, my dear, these things. See, E2 minus E1 is written as U2 minus E1 plus half into M V2 minus V1 square plus M G H2 minus H1. See, if you see clearly, the air is flowing with very slowly. If I open, it will rush, but there is no change in velocity, right? Initially, it is going very slowly, 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 slowly. After that, it will get saturated. Mechanical equilibrium is achieved. So there is no change in velocity also. So this term is approximately zero. Change I am talking, not absolute value. It is a relative change with respect to the initial one. Similarly, the system is itself here only. It is not going very heavy elevations, not heavy elevations. So that this term h2 minus h1 also be approximately zero. So final value will be E2 minus E1 is equal to change in internal energy. Correct? U2 minus E1. This is the E2 minus E1 equal to U2 minus E1, which is approximately, which also I will write a negation here. Okay, this is the final energy equation. Okay, but I want to know what is E2, what is E1 also. See, E2 means final state having some properties. Definitely it will having some internal energy at state 2. E1, mass M1, P1, T1, definitely it is having some energy, that is E1. That is clear. Okay, so my energy equation is like this now. We are landed with energy in minus energy out, which is equal to U2 minus E1, because E2 minus E1 becomes approximately equal to U2 minus E1. Not equal, approximately equal, because these energies are neglected. Correct now? This is the final equation of the energy equation. This is very, very important, because if you know this concept, then every question you can solve. So I will go to next board. We are landed with this equation again, E2 minus E1, which is equal to U2 minus U1. Okay, sorry, not this one. Energy in minus energy out is equal to U2 minus U1. Okay, now I want to see what is E1, what is E out. Already you know U2, E1, because at state 2 this is the internal energy, at state 1 this is the internal energy. What is E in into the control volume? See, when balloon is just fitted to the valve is closed at that time. Whenever valve is open, the mass is entering, right? Whenever mass is entering, mass is not coming alone. It will take some energy also. So which energy it will take? So some mass in is coming. It will take some enthalpy, because the fluid having some enthalpy of Hp quantity of air. So Hp per unit mass, because we are multiplying with mass only. So that it will in joules only or kilojoules. So V square by 2 plus Gz. Correct. And also see, this balloon is expanding, so it is doing some boundary work also. So boundary work will represent W. Similarly, there is a temperature gradient from state to state 1, so there will be heat transfer also. And because ambient conditions we don't know as of now, if it is definitely there is a gradient, so that there is a heat transfer. We will see whether it will going into the system or out from the system. Examiner will specify, that is not a problem. And Q into the system plus W into the system. Okay, and energy out. Similarly, I can write, there is no mass out to the control volume, so this term, all term will be 0. Correct? There is no mass out from the control volume for this condition. 0 plus Q out plus W out. See, in this equation I can tell you one thing also, there is no work input also here. Work input is not there, na? 0. See, clearly it is going into the system, there is no work also. Correct? Slowly going, very quasi statically going. Work input is 0. correct? So I can write energy in mass in plus enthalpy in plus Vp square by 2 plus Gz plus Q minus energy out, Q out minus W out is equal to change in internal energy, correct? For this instant, slowly velocity is coming, so velocity is very negligible. If I square up this negligible value, this will become very negligible value. And also there is no datum also, because see, the balloon is itself here only, it is not going higher elevations, so balloon is stationary only, just expanding. So this is also approximately 0, this is also approximately 0, tending to 0, okay? Mass in times enthalpy of the pipeline air plus Q in, if it is Q in, or Q out equal to W out equal to change in enthalpy of the system, okay? If you know all quantities what are there in, it will specified in exam. See, mass in already you know, I have already specified m2 minus m1, because there is no out. Hp already you know, for air, if you, air is ideal gas, so that Hp equal to Cp into Tp. Tp already you know, means this examiner will specify the temperature of the air in the pipe, okay? And Q in, if it is Q in, then Q in, or Q out is Q out. If there is temperature gradient, means the temperature of the balloon is less than the temperature of the ambient, there is the Q in to the system, or else it is higher temperature than the ambient, then it's Q out, right? In these two terms, in only one of the term will be there, one will be cancelled out, means one will be 0. And work out will be like which process undergoing is this thing, work out will be in this one. And change in internal energy, you can apply mcv delta t, because change in internal energy, air is treating as ideal gas, okay? This is the concept of the unsteady state condition. We will try to solve one question and we will finish it, okay? All data I will give. This is famous example, maximum I think so around 5 to 6 times this question is repeated in GATE exam. What I am about to tell, the question. That is very good example for unsteady state condition. You can see same, a pipeline is there, the pipeline is insulated, and which is connected to the rigid body or rigid tank, okay? A rigid tank will be there, continuously air is flowing, and don't forget there is a valve mechanism. The moment when I open the valve, what will going to happen, this air will rush into this system and it will fill, but the condition is here, it is going from state 1 to state 2, right? State 1 to state 2, but the at state 1 is evacuated, means fully evacuated tank I fitted with this valve, means there is no mass at all. If there is no mass, there is no pressure also. If there is no pressure, there is no molecules, what is going to happen? The temperature of the system will also be 0, there is nothing, vacuum, hava, okay? And at state 2, because we are filling na, some mass is there, correct? Some mass is there, some pressure is there, some temperature is there, these parameters, all quantities are there. So here my energy also 0, means dead state. In thermodynamics we will call system is in dead state, because there is no properties. If you want to specify the system, you need properties also not there, then how you will define the state of the system, correct na? So this state energy is 0, okay? Now I apply the mass conservation, energy conservation, same in one line answer you will get. This is my control value, because you need to specify the system, then only you can solve the problem. Mass conservation. Directly I am writing because you know already. Infinite interval term. This is also not continuous system, na? This is also process taking place in finite interval of time. Mass conservation I am writing. Mass conservation directly I am writing mass in, mass out is equal to change in the mass of the control volume. Correct. There is no mass out of the system. Correct. There is no mass out is equal to 0. So whatever the mass is in, which is equal to the change in mass of the control volume. Initially, if you see, initially mass m1 also 0. I forgot to told you here. So m1 also 0. So this term is not there. So whatever the mass is entering, which is the final state of the system. Correct. Mass conservation is over. Simple. This type of questions only will come. And energy conservation. Energy out is equal to U2 minus U1. Okay. Which is also insulated, my dear. This is also insulated. Means there is no interaction with respect to the surroundings. Means there is no work interaction, there is no heat interaction. Only just system is undergoing the mass transfer. That's it. But this is open system. Out is 0. Initially there is nothing is there, no property is there. So internal energy is a property of the system, na? So this is also 0. Energy N is equal to U2. How much is energy is entering? So there is no mass, there is no energy interactions like heat or work. Only with respect to mass it is coming in, right? So mass in is equal to directly enthalpy of entering. If I take HP or H1, or you take HP only because pipe, right? HP, and there is no velocity and acceleration due to gravity with effect of potential energy. I am telling there is no such type of energies, because with respect to this one, that is those are very negligible. So I am not taking those things because see those are 0 already. There is no heat and work interaction, directly U2. Correct. What is the mass entering into this system? M2. Correct. Is HP, which is equal to U2. Here the question is asking, I didn't told the question properly. See, a pipeline is there, air is flowing into the system. Initially the tank is evacuated. There is no temperature initially, there is no mass, there is no pressure. After the filling of the air into the system, what is the final temperature is asking. Examiner asking is the final temperature of the system. I want to find this one. So that I am applying the mass conservation, energy conservation. This is the one I want to find. Sorry for interruption, because this is my duty to tell you that what we need to find, right? So the final temperature of the tank we need to find. This is a rigid tank. Rigid means, you know, right, there is no change in the dimensions. And that means in fact it is not changing, undergoing any volume change when the force is applied or anything. Means here force is not applying because only air is flowing inside, air will exert some pressure, that is nothing but force, right, indirectly. So which is equal to, I can write U2 equal to M2 into small u2. Correct. U2 is the extensive property, my dear. Extensive property. We will see in basics of thermodynamics. M2 into U2 we can write. M2 it's cancel. Correct, na? HP equal to U2. I can write HP as Cp times Tp, which is equal to Cv times T2. Correct. I can write this one T2 equal to Cp by Cv times Tp. For ideal gas, because air is treated as the ideal gas condition, right? T2 equal to Cp by Cv equal to gamma na, equal to Tp. If you know the properties of the air, gamma is 1.4 and Tp is what is the temperature of the flowing fluid in the pipeline. If you know this value in Kelvin, you will get the value in Kelvin. If you know the value in centigrade, you will get in centigrade. But absolute temperature only we need to talk. See, because gamma represents kilojoule per kg Kelvin. Means gamma is the ratio. Ratio means dimensionless. If you take value as Tp as in degree centigrade, you will get in degree centigrade. If you take a value in Tp in Kelvin, you will get in Kelvin. Correct? I hope this concept is clear, because examiner is asking the final temperature only. We will stand with the this value. This is the unsteady state problem. If I want to tell you one more thing, see, there is a out also. Air is going out. Then this term is not going to 0. This term will be there. How much M2 is out is going, then we need to find out here using first principles ideal gas equation. This is the final value of the T2. If you know the value of gamma, gamma is the dimensionless term because this is Cp by Cv. Cp and Cv values, Cp units are kilojoule per kg Kelvin. Cv also same thing, because ratio means we need to have same quantities of units. Gamma is a unitless, so Tp, whatever the units will be there, it will be same. But we need to take the absolute value. Absolute scale in thermodynamics is the Kelvin scale. Okay, my dear friends, this is the concept of the unsteady state condition. You can solve any question. Thank you.